All right, good morning, everybody. Welcome back to another session of Breakfast with Data. And this our data modeling series. This is day 3, and today we are going to be looking at denormalization, and we'll look at the read-write trade-off. Yesterday we spent our time learning normalization, understanding normalization, giving every fact exactly one home. We looked at how business process sometimes may translate to data modeling, and why data modeling should come from the need of the business, what you're trying to achieve with your business. And that's one of the things that we looked at yesterday. Today we will be looking at one of the things that we try to look at with normalization is normalization helps prevent three specific kind of anomaly: the update anomaly, the insertion anomaly, and the delete anomaly. So you don't want to mistakenly update something and it doesn't update everywhere. So if a fact, each specific fact of the business is tracked based on just one table, you are able to update it. If you want to update a customer name, you don't need to go to the orders table or the orders that that particular customer has made in order to update the customer name. Or if you want to update, maybe customer name doesn't change quite often as a customer address, for example. So say you want to update a customer address, you don't have to go to every place where you have that customer's address and be changing them one by one on every row. So the whole approach is that when you normalize, you have optimized for fast write, right? So write also can mean update, right? And if a customer, let's say, changes their phone number, which is very, very important, you only need to change the data in just one row on one table. As opposed to if this phone number now has been linked or attached to every order that this particular customer has made, every order line item. So you are talking about millions of, if maybe a customer has made 1,000 order or hundreds of orders in a particular listing, going across several tables can be more expensive than, and the integrity of preserving the data at operational level is very, very, very important. So today we will look at denormalization. Denormalization is exactly the reverse of normalization, right? When we are, it's more like we are undoing what we are doing. Again, like I said, when you are modeling data, there is no Swiss Army knife of data modeling. What you are trying to achieve is what you try to optimize for. So, what are we trying to achieve when we are doing normalization? Normalization, we want quick write and the integrity of the data. You understand? Because this is what we are using to run business. One fact in one place. So changes touches one row and the data can never disagree with itself, right? The cost is paid later when we try to read the listing, and there are specialized databases for this kind of operation. So databases, when you look at operational databases, MySQL, SQL Server, Redis Cache, different operational databases, right? Maybe it's a catch, it's a SQLite. All these are optimized for this kind of storing this kind of data. You understand? Processing this kind of data. They are the traditional relational database engine. In fact, you might even see that some NoSQL databases actually work very, very good as well. MongoDB depending on what you are trying to achieve, right? It depends on how your data is structured. So again, modeling your data the right way in normalizing, we are trying to optimize for data integrity. The normalization, it's more about read because we are doing calculations, right? Joins with aggregates is going to cause problem. You understand? So the answer is almost always sitting in a pre-assembled table, right? So part of our ETL step, you might be asking, you remember that my let me go to a Scali draw. Remember that my analogy yesterday that data from analytic operation, I always go to analytica, right? And this is the entire job of a data engineer, a data practitioner, right? In between this process is your is where you have your ETL, right? From operational to analytical. So when you make that jump from here to here is where you are going to be able to do your what is it called, your transformations. So all these joins that we would have been doing here, suppose we want to have some sort of analysis, right, on operational data, instead of doing all of that, and that can be happening, we materialize a particular table in the analytics dashboard that we already do the pre-joining. In a later part of this session, we will look at the medallion architecture where we are syncing everything into the raw first, which resembles the operational. Then we do some transformation, some adjustments, some this thing. Then when we materialize our model, which is something that we have now built, we've done all those joins and everything that is needed in that aspect. You don't need to redo the joins again because you have what do we call this you have done all your mergings, right? You have merged, you have uh, brought all the data together, you just query. And these queries can be very, very heavy. And there are special kinds of databases for these particular use cases, which they are optimized. You have the columnar databases. These are databases that are in your data warehouse that are specially engineered for this kind of query. Some of them, in order to even be good at what they do, don't even have the concept of, they don't have the key constraints that you will have in the operational databases, right? Which is the integrity. You understand? Having, because when you write a particular table, you might put a key constraint. What is that key constraint? A customer who does not exist on the customer table cannot place order. You cannot have that customer because customer ID on the orders table is a foreign key, right? When you want to insert that into the orders table, there will be a constraint check that, hey, does this customer already exist? You understand? Because that is an insertion, that would have been an insertion anomaly, right? And that is the whole essence of us um, having a table for just that this thing, so that we know that okay, this customer does, we don't have a orphan customer because in another step, let's say you did not properly do that. By the time you get to the rider's table and the rider needs to call the customer, only for him to find out that this customer does not have phone number or the customer name does not even exist in his own system. That becomes a very, very big problem. Or if you are doing something, let's say you are doing it, you did not update very well, the customer address have been updated on the orders table, right? When the customer made the order, I said, hey, please deliver this order to this particular address of mine, only for you to get to the rider's table, the address, the shipping address is the old address that the customer put. Again, there is a lot of issues that can come in there. You might rather have an address table that is just link a customer ID, this thing, billing, shipping address this is the current something. There are a lot of logic that you can use in that case. So again, it's not that normalization is better than denormalization. No, it's the right tool for the right purpose. So for operational use cases, we try to normalize because we are optimizing for write and for data integrity. For analytics, we are optimizing for read. So here we don't mind multiple joins, right? As long as the data is of good integrity. But over here, we try to reduce join to the barest minimum. If it's possible, we just want one flat table, right? We have a wide table here. Here we have small tables. Here we have bigger tables, right? Because lesser number of tables, more table. Here, we try to prevent redundancy here. We don't mind redundancy here because redundancy can actually give us the speed. So again, this is a case of you cannot eat your cake and have it. You cannot optimize for operations and analytics at the same time using the same model. That is the whole matter of the day. Let's look at a few examples. I have actually gone ahead to write some things in our Databricks this thing, and this is I created a new schema called modeling sandbox. You are familiar with uh, our Lagos logistics data set. So if we run this now, and we have that, make just double checking to make sure it's ready, because sometimes Databricks can just decide to sneak up on you. Fine, I think everything is fine. Just one more process, and we are good. And of course, you can see what is going on here. There's another way to look at things inside your notebook. You can see exactly how many what's the duration of each of these sub task that is going on. So again, now let's look at this. So we have three tables here, right? The order item, which is the last green of the table. This is the most granular. This tells us what you are ordering from, what you are actually ordering. So in this case, we have inserted 5 order, just like yesterday: jollof rice, water, fried rice, coke, and suya, right? So we saw that these are actually coming from 3 different orders, right? Order number 1 is A below, which is jollof rice and water. The second order is this last one, which is coke. Then Okafor ordered for just suya, right? Suya, and I think he also ordered for okay, coke and fried rice. Bello ordered for coke and fried rice second in a second order, which is L1003, which matches to this. So this is a 3NF kind of table already, and we can actually, let me open another distance so that we can see those tables. We can say select star from orders, right? And let's run this, and I can just copy this guy. You can see, in case someone wants to, of course, because we are doing SQL. Oh, I think we can actually do this and other items, right? Other items, okay. Items, and can do restaurants, right? And we can select stuff from restaurants. So let's run this now and have this. So show to, so we see these are the different, these are the two tables. This is the uh orders table that has the order ID, customer ID, and this thing. This is in the third normal form. Customer restaurant ID depends only on the order ID, right? It doesn't depend on the customer. Customer itself depends on the order ID. Of course, if we try to go data quality route, data integrity route, instead of customer, we have the customer name, first name and last name, and other information. But this is more for practical sense, right? So now we have the order item which lists everything, and if you look at this, this is also in the stored normal form. Everything depends on the order ID and the item. You understand? So the order and the item. So there is nothing that depends on maybe the item alone or the distance. If quantity only depends on the item alone and not the combination of these two, right? Then that becomes a partial dependency, right? Because if we have a column for spicy jollof rice, maybe jollof rice is spicy or something, or suya or chicken suya or something. If we have a column for that, that only depends on jollof, right? Maybe spicy only depends on jollof and not on the particular kind of order. Then we have a partial dependency in that particular case, right? So that's that case. So the quantity and the unit price depends on the combination of these to uniquely identify one order line item. Then we have the restaurant ID, which is the restaurant table, mama put and chow. And just in case you miss yesterday class and you are wondering how did we get into this, now let's say we want to do a just a join to know what amount of the, so if we run this now, we are seeing that for each of the restaurant, right, we are seeing the total number of orders that were ordered. So we see the sum total of, so Bello, what is your total? How much did you spend in per order, right? Instead of us saying, okay, we put all of this together. So we are looking at the quantity and quantity times unit price in order to get, and we group it by the order and the customer and the restaurant name and the city. So the order that you made from a particular restaurant, the total number, let's say the order is the amount is this, maybe 4 5. What is this one? Let's look at the order total from here. Can you see? So quantity unit price is let's look at that. This is order number one. So 2,400, 2,004. This is 2,600 for the first order. No, this will be times 2, right? And unit price, so that is what we get here, 4,800, right? So again, this is a calculation for us to be able to get just this. You can see the amount of what did we have to do here? We have to do 2 joins, right? We have to join this table twice. Join to order, join to restaurant, and do the aggregation that we are trying to do, which is just a sum of the quantity, item count, and stuffs like that. Now, this may be a big problem. Instead of doing this, we can always materialize this. Create a orders report table and just query it once. If it is for analytics purpose, and we don't need to always come back to be rebuilding this particular uh, particular table every single time. So let's go forward with our presentation deck, and we can see this. A simple early morning report. You just want a report of orders with customer, restaurant, and city, and the total. This has touched three tables. You understand? Three normalized table plus an aggregate clean stock. This is an expensive read, right? So instead of having that, if this is something that you do every day, it's like several day, every um several times in the day kind of thing, that you do in the morning, you do in the afternoon, you do maybe even after every single transaction, to know what is the totals and stuff like that. You might do it 4 or 5 times. Let's say someone wants to see the analysis or something, but if it is for purely analytics purpose, you can pre-build that table already in a denormalized way. So again, when you normalize table, this is going back to the whole idea that normalizing and denormalizing is not like one is a terrible idea, the other one is a good idea. Oh, let's always denormalize, let's always normalize. It depends on what you are trying to achieve. You understand? In normalize, if you if for normalization, right, one row changes, only one row. You understand? That's very cheap. It's very safe. It's not as this thing. Only one row that you do, maybe you insert or you update. That's like still overwriting when you do an update, right? No problem. Then for denormalization, many copies will change because the same record will repeat multiple. It can repeat multiple times. There is definitely redundancies. So when you want to do changes, maybe you want to update something, it's actually slower and it's risky, right? It's one of those things that I remember when I first started working, my boss told me then that when we build, and you see it it's very, very rare for you to find alter table in a particular uh in an analytics kind of, in your data warehouse pipelines. You understand? Maybe you write it in store procedure or something. We rarely alter table. We rarely do that in this thing, because that alter table that you learned in SQL and everything is very, very expensive in a data warehouse. Because remember, if you had one column, that column, so look at a table, maybe you have let's say you have this is our restaurant orders table now, right? And we only have maybe 200 restaurants on our table, but we have 50 million orders or 10 million orders, because many people are ordering from this thing. If we want to change something about a particular restaurant, let's say this restaurant has made 2 million orders, right? If we just go to a table that has just 200 records and we look for one record, we update this thing. That is easier and that is safer than if we are going to search for every what is it called, every of those orders. You understand? Maybe the restaurant name used to be Mama Put. You understand? And they changed to Mama Put More, right? And we want to update that with every order in reverse. There is going to be one is more expensive than the other. So when you are reading, when you read, most likely for normalized, you are going to encounter joins. And what did we learn about joins when we were in the SQL series? we discovered that joins can make your queries slower. If the more joins, the more time you spend. So joins are more expensive than this thing, because the table is going to do a full scan depending on if you apply filter or if you did not apply filter. If you are using Spark, like we also see, you might do some shuffles and stuff like that. So if you don't partition your tables very well, it can even lead to more issues. So you expect more joins on every query just to read out information. In denormalization, few joins, and it's very, very fast, right? The integrity of the data, it is enforced by the structure. You understand? Now, for denormalization, you have to, in fact, there is always this checklist of, there are tables that you must load first, especially when you are doing fact and dimension for your fact tables and your dimension tables. You want to load your dimensions table first before you load your fact table. So there is a process to that, and those processes you manage it in your pipeline, in your own data pipeline. It's not like it's inbuilt into the whole system. A lot of normalized table for tables in operational OLTP kind of tables. We also have what we call, those database will also be ACID compliant, right? You can go read about ACID compliance later. It's all about this data integrity. So a table in for normalization, the table is normally less heavy than a data warehouse, right? Or when you denormalize, because when you denormalize, you introduce redundancy, right? The table gets bigger, and depending on the kind of analytics that you're now doing, if you are keeping history of every change, which is a very, very common practice in your in your database, you will be seeing a lot of you will see a lot of you have a lot of tables, a lot of things. Maybe every time a customer change address, you're keeping track of the old address and everything. For operational use cases, you don't need that. So what is it best for? Every write transactional table, that is when you use normalized. You normalize your thing, get it up to 3NF, BCNF if it's possible. Then for denormalization, this is read heavy. Analytics, when you are doing analytics and you are trying to do uh, um, um, reporting. Let's quickly take a look at, because I just want us to also, as we are doing some things, let's run this now. This is like we have pre-built this. Now, suppose we want to read from this now. We can easily just write a select, and we don't need to do join. See, can you see that when we have materialized this table now, we are doing select now, we are not doing join. And if you look at the query performance of this, it's going to be way, way, way better for this. So this entire query now completed in 1 second, 75 milliseconds or something. This, just take a look at this, right? So if you go back to this other query, let's look at this, because you're going to see several. Can you see? This one is almost twice that, more than twice safe, right? Of what we have here, right? And what we are, and this is 4 different tasks that were completed, though, as against this one that is just 1 task. You understand? And if you are looking at the size as well, those 2 rows that were read, here we have 3 rows more this thing, of course, that the size is actually about the number of columns and rows. There is a mathematical calculation for that. This one has lesser rows and lesser columns, so it's going to be lesser in terms of this thing. But what is determining how big this guy is that number of join, assuming they are running on the same system. Now, note that there are several different database engines that are optimized for that. All we need to do is we can do refresh, right? If we just want to normalize our this thing, we can always refresh our table every time we want to create it. Don't worry, we'll still create a full when we get to next week is our Kimball approach, where we'll build a full this thing from scratch. Let's know how we denormalize. So you will see a real example using this, what kind of tables we are going to put in our bronze, in our silver, and then our gold layer. Now, suppose you want to, let's just look at our old table, right? This is already a table that we already have before, right? We can see this same this thing now on this our old table, and as you can see, this is still huge. There is a lot of rows that were read into this. What we can use for this one is to build a kind of like a staging table where we materialize everything, right? So instead of you doing the joint as at the time that you need it, you would have already done it maybe when your pipeline is running, when you are bringing data from different places, you already kind of like pre-aggregate your table. You just select, because this aggregation, sum and count and all the rest of them are already done before time, and that way it's easier for you to just do your read, and your query uh is more smoother. So what are the decisions when to denormalize? Denormalize when all these three are true. One, read is heavy. You read the shape far more than you write. So if, and that this is the case for a lot of analytics workload that you do. We rarely write data in analytics. The only time we write data is when we are moving from one table to another to calculate this thing, and you might do, and a lot of time is all about inserting. You understand? Insert into a table as select, right? You are selecting the insert into the table, not that you are trying to write new records or update existing records on that particular table. So when read is heavy, you are doing analysis, a dashboard, thousands of read thousands of times per day. You know, different people will be refreshing, will be looking at it against a particular table. So it makes sense to pre-aggregate it once, right, and serve it, especially if you can do t minus 1. Like, you don't need to be doing the transformation. Nobody needs to know what is going on a per seconds basis, because at the end of the day that becomes a huge problem. There are other systems that we use for stream analytics, but for batch kind of analysis, right, where you need to be able to do to get this thing, you don't mind a time off, you are fine with denormalizing, right? When there is a stable pattern, the query shape really changes, right? Analytics, what you are trying to do is very stable. You already know total number of customer per day, how many people bought from us, How much are we selling on average? How much have we made today? What we made today, how is it different from what we made yesterday? What is the comparison between what we made today and what we made last year? On a month to date, what are we doing? All those kind of information are fairly standard in the organization, right? So if you have to do that, your you should normalize your table to make sure that that makes a lot of sense. Now, also, when stillness is tolerable, right? When you don't need uh real time this thing, right? You don't need the exact, if you are selling, maybe you need the report per hour, or you need the report at the end of day, or you are consuming report from yesterday and you might be consuming it 50 different times. So if we've pre-aggregated it, there is this thing we call T minus one when we are doing batch reporting. T minus one and if you work with banks and all the rest of them, you would have heard of things they call end of day, right? So end of day might end at maybe 2 a.m. or when all your end of day processes, meaning or 12 midnight, right? Meaning all the transactions, when you are doing analysis today, what you have in your analysis is all the transaction as at 12 midnight. You understand? So every other thing that comes after, because we've not materialized the table, we've not pre-joined those tables again, right? Will be just a little bit stale. And most business folks know how to deal with this, because T minus one kind of give you, this is where we are as of this thing. But there are certain analytics that you need near real time report. Those ones have a special what's it called, special database that they use in order to achieve that particular um that particular uh that particular this thing is the message queue. And what is the other one? Message queue. I'm forgetting the other stuff. But when you hear things like Kafka, RabbitMQ, all those ones are more geared towards stream analytics. But different patterns for different, let's say, different stroke for different folks. These are the three key decisions that you need to um, get. And at the end of the day, this is what things will look like. We already saw this table, the normalized. We have the order ID, the restaurant, the city, item count, and the total, orders total. So this is an aggregated column, right? So let's say we even have another roll up of this same, like we want to see how many orders were made for a particular restaurant in a day. So instead of order ID, here we have restaurant ID, then we would have merged. So we just have Mama Put, Ikeja, and this count will now be 4, right? And this will be, what is it called? 4,800 plus 5,000, uh, 2,500. That will give us, I think, 7,300 if I'm not mistaken, right? So that kind of aggregates all of that. So these joins have been pre-computed, pre-aggregated for us. It's actually way faster. It's just like you are writing select from just one table. All you need to do is to apply your where clause, which is also determined by or should be determined by how you partition your, or is what determines how you will eventually partition your data. Because in when the data gets this big, and that might be a question that might be coming to your head now, that when the data gets so big, how are we going to deal with it? It's very large and something. There is something we call sharding, how we split these tables across different what is it called, different nodes, different clusters, in different nodes in a cluster of computers, that makes everything even faster. What are some what is the discipline? Deliberate redundancy as an owner, right? The redundant table from today and the messy table from day two looks almost identical, right? So if you look at the query that we wrote before we did pre-aggregate, it's almost like the same thing. But at the end of the day, it is whether anyone is responsible for keeping the true copy or not, right? If you accidentally, you are just writing things, you're putting redundancy, no plan, no schema, you just write this thing, you might enter into an update anomaly, right? Remember that the starting table, when we started the the table that we started with, is almost like the one we ended up with after we denormalize. So it's kind of like reverse. In I'm coming to you doing for normalization, it is deliberate. The data engineer, there are jobs and there are pipeline that rebuild, that check. In fact, you have data validation gates, data quality gates, and all these things. But on the other one, there is actually no plan if you are using it, and that is a live production table that is used to run business. If it's operational, there's a problem there. If it's for analytics, that's fine. The staleness is bounded. You understand that, okay, it's t minus 1, everything stays true. That is on purpose and that is deliberate. It is something we can plan for. Doing, your hand is up.
Okay, good morning. Uh, Sorry for bringing you back. I always say a concept. They always say, what is the single source of truth? I don't know how it is related to this class.
Okay. Single source of truth is actually related, but it's another concept, right? Here we are talking about modeling data. Single source of truth is the repository. The whole idea of single source of truth, and that comes from when we are doing data quality and data uh, one thing we call master data, right? You don't want to have, let's say, and it's always a problem where you have data silos. And this is something that I've encountered in several organizations, right? Let's say marketing has their own data set for customer, and their customer data set has 1 million records, and sales have another this thing and their own data set is 1.2 million, right? Let's now say accounts now have another record. This is because they are all using different systems, and the way the system even calculates sometimes, and you might have some problems, right? And in order to get the single source of truth, you want to know where is this data coming from, where did it enter, right? And at some point you can aggregate some things and put it together and say, look, this is um my source of truth, right? This is what the organization says, this is clean data. Every other this thing fits from this particular data, and it's some engineering and governance process that we go into that. So how you model the data there, things around integrity and stuff like that, it's very, very important. Sometimes your source of truth is always living somewhere between operational and analytical, because sometimes this operational data is very raw, is might contain some dirty stuff, And then you have your single source of truth uh, somewhere after you have ingested the data, you have aggregated, it has passed through validation gate. I am part of the shift left movement, because if you see the left we are talking about it, because most analytical data will come from operations, right? So the event must have first happened. Now the chief left idea says that operations is where you should catch the dirty data, because the biggest headache of us data practitioner is dealing with data that is not of the quality that we are looking for. And that is one of the things we call dirty data. Dirty data can mean a lot of things. Data of low quality. Quality of data has several dimensions. Is it missing some information? Is it accurate? Does it reflect what it captured? You understand? A lot of those kind of things. So you might say, oh, my single source of truth is the system that is capturing the data. Well, someone just entered someone else's phone number. uh, is that now truth, right? And that tells us again, if you have single source of truth, is where you should change the data. If you want to update the data, we go to the source. If the source is corrupted, everything downstream then gets corrupted. But there is also another school of thought that it is very, very difficult for you to achieve a single source of truth, for you to have a single source of truth. So the more modern approach is the single version of truth. Think about it like your spiritual books, like maybe your Bible or whatever religious book you're using. You want to make sure that the version you are reading is the same version we are reading, so that everybody can compare their distance. So if you have like a King James version or something, it's going to say the same thing, right? Depending on no matter where you read it at, right? It's not a single copy of truth, right? It's several copy, but it's the same version. And that is one of the things that when we get to week, which I could bring this thing up. I don't have it handy now. When we get to week 3, we are going to look at how this come into play when we go into data vault, right? Single versioning of the truth, right? And saying this is what our truth looks like now. This is what it ought to look like. I hope that helps you, doing.
Yes, thank you very much.
Yeah. So again, single is how where you store it. It's more of a quality issue, but then data modeling will impact your um, quality. That's uh, what I can say about that. Now, this is the our signature segment where we look at 3 things people get wrong. And if you go through the whole series since we've started, it's always 3 things, 3 things, 3 things. Number one, mistake number one is query pattern, denormalizing before you know the read. Premature denormalization is premature optimization. You understand? You freeze the shape you get, you will regret when question changes. So when you want to build what is it called? In analytics, there is something we call star schema and there is snowflake schema, and we are going to get to that place. There are some times that in your data warehouse, you actually want join. It's not like every time, oh, let's get one flat white table. You understand? Because when you have a dimension table that also has another dimension table, when you have a nested dimension table, you already have a snowflake schema, and that introduces another step of join. But sometimes it's actually efficient, it's actually expedient for you to do that one that way, because you know the way your query is coming, you know the way the business is asking question and how the business segment things. You understand? Which lead us to the second one, business alignment. Copying data with no owner. You reintroduce redundancy, build but no refresh, right? Nobody owns the pipeline. Nobody is the data owner. I mean, these are data governance issues that you must already think. This is why the job of a data engineer sits in the middle of everything, right? Try to understand everything, try to foresee things. Again, if you think you are smarter than the business because they cannot write SQL, you are making a huge mistake. Because at the end of the day, they are the ones that are going to tell you how they do analysis. What is when I started working with, in fact, there are a lot of accounting terms that I have now learned, have known, because the business explained it to me. You understand? Sometimes when you sit down, you think, you know, you do this thing. At the end of the day, when they start using your, what is it called? Your analysis or your report, and things are either slow, the report quality is not, they will just stop using it. And that is what you don't want, because this is your work. Your work is to help the business get value out of their data. If business does not trust your data, they cannot get any value out of it. They won't use it. The grain also, so if you are treating, another mistake is treating, um normalization as bad. 3NF is good, denormalization is bad. That is not the right approach. You understand? The best thing is, what do I need? Do I need right? Do I need this thing? Going by this decision, right? Is it a good time to normalize or a good time to denormalize? It's not one is good, one is bad. It's what do I need for what I need to, for decision that we are trying to make. This is not a contest between this thing. There are times that now, as data practitioners, a lot of our data sources are going to be normalized already. You understand? So a lot of times we don't do normalization. We do more denormalization. But that doesn't mean that we shouldn't understand the normalization concept. Normalization used to be a very big interview questions that year. I don't know if they still ask it again. Um, um, but that that used to be the big deal, the hallmark of every interview that I attended around 2018, 2019. Always have the question, first normal form, second normal form, third normal form. You have to explain it in a lot of the interviews. I don't know. I have not been asking people. Maybe it's me that is now doing the interview. That's why I don't know if they are still asking. Those of you that are still going through, going to interviews for more junior position, you can let me know. It's just that in my interviews, I don't ask those questions. I ask fact and dimension, data warehouse and related kind of question. Maybe I should start asking it just to ruffle some feathers in the interview process. But it used to be very big deal that year that we have people, we actually go and watch the video on normalization and denormalization before you go for any any interview. Now this is where we've landed. Spend redundancy like money, right? You need to know the trade-off. Normalization, optimize write and integrity. Denormalization, optimize read. Normalize only when read dominates. The shape is stable and stillness is tolerable. So maybe t minus 1, end of day, kind of calculations and all the rest of them. Batch analytics, right? When you're doing batch analytics, the technique, pre-join, that is what you do when you denormalize. Redundant column, pre-compute aggregates, and a grain is chosen for the read. So always know what one rule represents. The discipline, deliberate redundancy as a owner and refresh. So you know who owns this, and it's always a pipeline or a job that is responsible for this. Tomorrow we will go to the conceptual data model, the logical data model, and the physical data model, because all of those things is just to build us up towards that. Because when you now start, you look at the conceptual, we start with the concept, then the logical, and the physical is what actually enters into your database. Any question? Okay, in the absence of questions, thank you very much. It's been breakfast with data. I hope you are having a great day. Enjoy the rest of your day.